Hi, today we're looking at Functional Skills Maths Level 1. We've got the Pearson Edexcel exam board. This is sample paper 1 and we're going to start with the non-calculator section. Question 1. A music festival sells tickets on its website. There are 120,000 tickets for sale. We've got festival news. 118,200 tickets sold in the first hour. How many tickets are still for sale after the first hour? You must show your working. Okay, so we know how many we started with. They've given it in words. Now we've got 3 marks for this question. We're going to get the first mark just by writing this number in digits. So 120,000. So that's going to be 120,000. That's mark 1. Now this is how many were sold and we want to know how many are still for sale. So we want to take that number off of the starting number. So we've got 120,000 minus 118,200. So we start from the right. 0 minus 0 is 0. 0 minus 0 is 0. We can't take 2 away from 0. We've got nothing to use for over here, so we're going to have to go all the way to the 2. We reduce that by 1 and pass 1 across to make that 10. We still want to get a number over here that we can take the 2 away from. So we'll reduce the 10 by 1 to make it a 9. Give the 1 across, and now we've got 10 here. So 10 minus 2 is 8. 9 minus 8 is 1. 1 minus 1 is 0. 1 minus 1 is 0. We can put our comma back in. So the number of tickets still for sale are 1,800. Okay. Question 2. Calculate 12 squared. Okay, well 12 squared, the squared means that you multiply it by itself, so 12 squared is going to be 12 times 12. If you want, you can split it up into 2 times 12 and 10 times 12. I'm just going to do it as a column. So we'll do 2 times 2 is 4. 2 times 1, or 1 times 2, is 2. Now we move on to the 10, so we put a 0 down here. 1 times 2 is 2. 1 times 1 is 1. We need to add these together. So 4 plus 0, in fact we can put it right in the answer box. 4 plus 0 is 4. 2 plus 2 is 4. And 1 is 1. So 144. Part B. Work out 80 minus 6 times 2. Now you're all going to know, because of your order of operations or BIDMAS rules, that you need to do the multiplication first before we do the subtraction. Well, 6 times 2, so we've got 2, 4, 6, 8, 10, 12. So we can put that in here. So we've still got the 80, but instead of 6 times 2, we're subtracting 12. Now we can do this as a column. 80 minus 12. We can't take 2 away from 0, so we reduce the 8 by 1, and we make this 10. Now 10 minus 2 is 8. 7 minus 1 is 6. So we've got 68. Okay, part C down here. Work out minus 18 minus 14. So let's imagine we've got a number line here. If that's 0, well, minus 18 is going to be somewhere down here. And then minus, so we're subtracting 14 from it. So that means we want to go down this way, because subtracting we're going to go to the left. And we're going to go that way by 14. So it's going to be 14 more negative than 18. So in fact what we can do, we've got 18. We're actually going to add the 14 to it. 8 plus 4 is 12. 2 carry the 1. 1 plus 1 plus 1 is 3. So it's 32. But because they're negatives, the answer is going to be negative. So we're actually minus 32. Because we know it's negative number. Think of it like it's minus 18 degrees and it gets 14 degrees colder. So it's like we're adding the two numbers together, but the final answer is going to be negative because it's minus everything. Question 3. Rosa makes candles to sell. Each candle is in the shape of a cuboid of height 8 centimetres. The base of each candle is a square of perimeter 20 centimetres. Rosa needs to know the volume of one candle. Work out the volume of one candle. Remember to give units with your answer. So, the base of each candle is a square. And we've got a cuboid of height 8 centimetres. It might be helpful to draw a little sketch. So if that's going to be our 8 centimetre high cuboid, we've got this base, which is a square. So it's probably going to look something like that. Put that back line down there. Okay, so we know that this square base here has got a perimeter of 20 centimetres. Okay, so perimeter equals 20 centimetres. Right, so that means going around the outside. Now, if it's a square, in fact, let's draw a sketch of this square. If it's 20 centimetres all the way around, all of the sides have to be the same. So what we want is 20 divided by 4. That's going to tell us how long each of these sides are. Well, 20 divided by 4, let's do our 4 times table. 4, 8, 12, 16, 20. So that's going to be 5 centimetres each. So 5 centimetres here, 5 here, 5 here, 5 here. Now we actually want to work out the volume. Well, the volume is the length times the width times the height. Well, for us, because it's a square base, the length and the width are the same. So it's going to be 5 times 5. And the height, well, that's this 8 centimetres here. So we want to do 5 times 5 times 8. So it's up to you what order you want to do them. Let's do the 5 times 5 first. We've got 5, 10, 15, 20, 25. So it's 25 times 8. Now we can do this as a column. 5 times 8, 8, 16, 24, 32, 40. 0 carry the 4. 2 8s are 16, plus 4 is 20. So our volume is going to be 20, and it's centimetres cubed. In fact, we can write that down here, and they did say to give units with your answer, so 200 centimetres cubed. Now we've got an extra part here which says use reverse calculations to show a check of your answer. So reverse calculations, that means starting with your answer, try and get back to what you started with. Well, starting with 200, to get here we do 25 times 8. So we want to do the opposite, we want to do 200 divided by 8. So let's do that with the bus stop method. We say 8 can't go into 2. What about 8 into 20? What do you got? 8, 16. So it goes in twice. 17, 18, 19, 20. So 4 remainder. What about 8s into 40? 8, 16, 24, 32, 40. So that's 5 times. Okay, so we've got 20 divided by 8 equals 25. And then if you remember, we did 5 times 5. So we can now say, well, 25 divided by 5. And we saw 5, 10, 15, 20, 25. That gives us 5. And if we want to get right back to the beginning, which was the perimeter, which was 20 centimetres, well, we're going to need 5 plus 5 plus 5 plus 5 to get our perimeter. 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. We can do a tick. We've started with the answer and we've worked all our way back to what we started with. Question 4. Round 11.348 correct to 2 decimal places. Okay, well, here are our 2 decimal places. So we look at the digit afterwards, which is the 8. So if it's 5 or more, we need to increase the previous digit by 1. So that's going to become 11.35. Now we've got another part to this question. Rashid works at an animal centre. The animal centre sells tickets for 49 weeks of the year. A student ticket costs £9.90. The animal centre sold 23 student tickets last week. Rashid assumes that the same number of student tickets are sold each week. He wants to estimate the income from the sale of student tickets for the year. Estimate the income from the sale of student tickets for the year. So they said it twice, and the key word is estimate. So we don't need to do it accurately. In fact, they don't want you to do it accurately. They want to check that you can do some good rounding here. So what we would do, if we want to find out what the income was, would say, well, we've got 23 tickets times 49 weeks of the year times £9.90. That would be the accurate answer. Well, we're going to say, well, that's approximately equal to, so we're going to round these. So we round that to the nearest 10, so we can say it's about 20. 49, well, that's close to 50. And £9.90, well, we can call that £10. So 20 times 50 times 10. Well, let's ignore the zeros. 2 times 5 is 10, times 1 is still 10. And then 1, 2, 3 zeros go on the end. So that's going to be £10,000. And that's the end of the non-calculator section. Okay, so now we're going to move on to the calculator section of the paper. Okay, question 1. Ryan will drive his car in Spain. The speedometer in the car shows the speed in miles per hour only. He will be driving on a road with a speed limit of 100 kilometers per hour. Ryan uses this rule to find the speed in miles per hour. So he takes the kilometers per hour, divides by 8, multiplies by 5, and get miles per hour. Ryan thinks that 70 miles per hour is the same as 100 kilometers per hour. Is Ryan correct? Well, let's try it. So we want 100, and we're going to divide it by 8. We've got a calculator here. 100 divided by 8. 100 divided by 8. 12.5. Then we need to multiply it by 5. And it gives us 62.5, and that is miles per hour. Ryan thinks 70 kilometers is the same as 100. Well, that is not equal to 70 miles per hour. So is Ryan correct? No. He's incorrect. Question 2. Nicola wants to buy 30 litres of white paint. She sees this special offer. So white paint, a 10 litre tin. Usual price is £38, 15% discount. Nicola uses this special offer. She has a budget of £100 for the paint. Does Nicola have enough money to buy 30 litres of white paint? Okay, so let's work out how much it's going to cost. Well, if it's 30 litres, we've got 10 litres here, Well, if we do 30 divided by 10, it's going to tell us how many tins we need. Hopefully you can see that we can just cancel these, and 30 divided by 10 becomes 3 divided by 1, which hopefully you'll know is 3, but we can check it on the calculator. So we need 3 tins. Now we've got the price and we've got a discount. You can take the discount off of 1 tin and then multiply it by 3, or you can multiply the original price by 3 and take the discount off afterwards. It doesn't matter. I've got the 3, so I'm going to multiply that by the price per tin. So we've got our 3 times 38, and that gives me £114. So now we want the discount. So what we're going to do is we're going to work out the discount first. So 15%, so 15 out of 100 of, which means times 114. So 15 divided by 100 times 114, and that's 17.1, or that's £17.10. That's the discount, that's how much we take off. So now we can do £114 minus the 17.10, and this will tell us how much it actually costs. So this is after the discount, 96.9, but because it's money, we need to make that £96.90. She has a budget of £100. Well, this is less than £100. So does she have enough money? Yes, she does. Question 3. Luke wants to cover this wall with blue paint. He will buy blue paint in 2.5 litre tins. Each 1 litre of blue paint will cover 8 metres squared of the wall. How many tins of blue paint does Luke need to buy? So we want the area of this wall. We don't want the door, so you could work out the big rectangle and then take off the door. What I'm going to do is I'm going to split this up. So I'm going to have one big rectangle here. So the area of this rectangle, length times width, well, the length is 6.1 and the width is up here, is a 3.6. So again, we can use our calculator. So 6.1 times 3.6, 21.96, and that's going to be meters squared. Now we need this bit here as well. Well, we know this length is 1.6 meters. We need this bit across the top. Well, we know it's 7 meters all the way across, and we know it's 6.1 meters just to here. So this is the difference. So this is going to be 7 meters minus 6.1 meters. 7 minus 6.1 gives us 0.9 meters. So the area here is going to be 1.6 times 0.9, which is 1.44 meters squared. So our total area will be our 21.96 plus our 1.44, which gives us 23.4 meters squared. Right, we've got the area. Okay, we know he'll buy blue paint in 2.5 litre tins. 1 litre will cover 8 meters squared. So how many litres does he need, first of all, instead of looking at how many tins? So we want to do 23.4 divided by 8. So 23.4 divided by 8. So 2.925, and that's litres. Well, 1 tin is 2.5 litres. So 2 tins would be 2.5 times 2 would be 5 litres. Well, we know that 1 tin's not enough because this is more than 2.5, so we're going to have to go for 2 tins for 5 litres. So we can put, need 2 tins. There we go. Question 4. Chris is designing a badge. The badge needs to be in the shape of a trapezium and have a base of length 6 centimetres and also have only one line of symmetry. So draw a suitable badge, use the grid below to draw a badge, and we're told that each of these squares is 1 centimetre. Right, so what's a trapezium? That's what we need to remember first of all. Well, a trapezium is a 4-sided shape with 1 pair of parallel sides. So the standard shape of a trapezium doesn't have to look like this, but typically it would be this kind of shape, and these would be our parallel sides. They tell us that the base has got length 6 centimetres, so what should we do the base down here? Let's start a corner here. So we'll go 1, 2, 3, 4, 5, 6 centimetres. Let's draw in this base. Just do it a bit darker so that it shows up properly. Hopefully you can see that. 1 line of symmetry. So on this shape, the line of symmetry would be going down the middle there. So if this is our line of symmetry, maybe if we just come in 1 square, same on both sides. Because they haven't told us about the other lengths, just that the base needs to be 6 centimetres. So that's it. If you want, I'm going to just sort of lightly draw in my line of symmetry so we can see where it would go. But that's our badge. It doesn't have to look exactly like that. It could be higher. We could have brought these points in a bit more. Anything, so long as it satisfies these 3 requirements, it'll be fine. Question 5. Jimmy works in a shop. He has this information about the 72 items sold last week. So we've got tablet, phone and laptop. Sold 15 tablets, 44 phones, 13 laptops. We've got an angle size here as well. Now Jimmy starts to display this information in a pie chart. That's why we've got the angle size. Complete the pie chart for Jimmy. So this is what he's done so far. He's done the tablet section. So to finish the pie chart, we really need to know the angles that apply for phones and laptops. The way we can do that is we can say, well, if there's 75, well, this is going to be in degrees, 75 degrees when 15 are sold. How many degrees per item sold? So in other words, 75 divided by 15. So if we do this, 75 divided by 15. So it's 5 degrees for each item sold. So if we want to know the angle size for phones, we're going to multiply that by 5. And if we want to know the angle size for laptops, we're going to multiply the 13 by 5. So 5 times 44 is 220 degrees. And 13 times 5 is 65 degrees. And we can check, because if we add these all together, 75 plus 220, the total number of degrees in a circle are 360. And that's what we get. So that's a nice little check as well. So we've worked out the angle sizes. Now we need to finish the pie chart. So we've got an angle of 220 degrees to draw and one of 65 degrees. Now, if you look at this, if you think, well, actually, it's 2 angles, but really I only need to measure 1 angle, because once I put a line in wherever it needs to go, I'm going to have my 2 parts. So because a protractor only goes up to 180 degrees, I'm actually going to do the 65-degree angle. So I'm going to start here. I'm going to do it up on this bit. So line up the crosshairs here. Get the line straight. Now, because we're starting here, this is the angle we're measuring this way. So we're going to start with the black numbers because we've got to start at 0. So 0, 10, 20, 30, 40, 50, 60. We wanted 65, so it's going to be right in the middle. So I'm just going to put a dot there. I can use that to draw that in. So if you remember, the 65 section was for laptops. And the bigger section, whatever's left, well, this must be for phone. And there you go. Question 6. Ben is an activity leader. He is planning a team building event for a group of people. Ben has this part of a map. Okay, so we've got point A and point B, and on both of them we're showing where north is, straight up here. Okay, I'll move it up so that we can see. Can we get the question in as well? Yeah. Okay, in fact, let's have all of that. Right, so we're told the group will start at point A, so here, and walk directly to point B, here. Ben needs to write instructions to give to the group. The instructions need to include the bearing and the distance to be walked. Write the instructions for the group. Remember to give units with your answer. Well, I'm going to draw a line on first of all. We're going from A to B. So we want to know how far is this? And they said the bearing as well. So the bearing is, if you start looking at north, what is the angle round to the line that you've got to walk on? So let's do that first. Let's work out this angle. So I'm measuring here. So I'm going to start with my protractor going straight up. Let's bring it down so we can see. So if I get that on here, line it up. Now, because we're starting here and we're going this way, we're going to start with the blue numbers because we've got 0 and we're going to get bigger as we're going round. So make sure we've got that all lined up. So 10, 20, 30, 40, 50, 60, 70, 80. Remember, we're going all the way around until we hit this black line here. And it's all the way down here. It's actually 110 degrees. Okay, so that's going to help us with the bearing. We need to know the distance to be walked as well. Well, we can measure that. And that is a nice exact 1, 2, 3, 4, 5, 6.5 centimetres. Okay. Now they're not going to walk 6.5 centimetres. That wouldn't be very far at all. It tells us that 1 centimetre on the map is 1,000 metres on the ground. So we need to multiply our 6.5 times 1,000. 6.5 times 1,000, and that is 6,500 metres. If you wanted to say, well, that's 6.5 kilometres, that's fine. It doesn't matter so long as you state what your units are. So now, all we need to do is to say what the actual instructions are for the group. So we're going to say, walk 6,500 metres, or 6.5 kilometres, up to you, on a bearing, so this is like saying in the direction of, and it was 110 degrees. Part B. Ben records the time it took each person to complete a different event. He is completing a table with information. So we've got the mean, it's 39 minutes, the range is 26 minutes, The longest time is 53 minutes. We haven't got anything for the shortest time. Complete the table. So in other words, work out the shortest time. Well, I know that the range is the longest minus the shortest. Well, we know the range is 26. We know the longest is 53. So 53 minus something gives us 26. So we can swap it around. Well, we can say, well, if we do 53 minus 26, that's going to tell us what the shortest is. So 53 minus 26, well, it must be 27. And we can test that now. Because if we do 53 minus 27, it does indeed take us back to 26, which we've got as a range there. Okay, question 7. The table shows the price of a cup of tea in 5 different cafes. So A, B, C, D and E, they're all slightly different. Calculate the mean prices of a cup of tea. Well, the mean is the total divided by how many we've got, or the frequency. So we want the total, so let's add these all together with our calculator here. So £1.80 plus £1.59 plus £1.65 plus £1.45 and £1.70. So we get £8.19. How many have we got? 1, 2, 3, 4, 5. Divide it by the 5 and we get 1.638. Right, but this is money, and with money we have pounds and pence. So we only want 2 decimal places. We've got 3. So what we do is we look at the next digit, which is the 8, and say, well, if it's 5 or more, we need to increase this by 1. So it's going to be £1.64. Okay, question 8. Here is a cube of side length 3 centimetres. Okay. So because it's a cube, they're all 3. That's 3, that's 3, that's 3, but that would be 3, that would be 3. Draw a net of the cube. Use the grid below to draw your net. So think of a net. A net is taking the 3D shape and flattening it out into a 2D picture. Now what I'm going to do on here, see if this helps, is just to help us to sort of visualise this shape. Okay, hopefully that helps. Okay, so although we can only see that bit, we've actually got a front and a back, top and a bottom, and a left and a right. So we've actually got 6 faces there. So if we were going to flatten that out, we would actually end up with what we're going to have 1, 2, 3, 4. So that would be like the front, base, back and top, and then we'd have 2 bits on the side, which we can put on like that. So that's just a rough sketch of what it's going to look like, and all of those lengths are 3 centimetres. So we need to draw that more accurately on here now. So where should we start? I'll start here. Now our first square, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, and then if you remember from the sketch, we want 4 of these squares in a row. So we're going to have another 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Same up here. Okay, so that would be my 4 squares. I'll try and make these lines a little bit more defined. So we'll have the 4 squares there. And also if you think of a cube, or think of it like a dice, on a dice you'd have the numbers 1 to 6. So we know that we're going to need to have 6 squares altogether. So although we've got 4 at the moment, we're going to need 2 more. And these are the 2 that I'm going to put them off here. I'm going to make it like a cross. So 1, 2, 3, and 1, 2, 3. Now there is more than one way to draw the net of a cube. This is just one way of doing it. Many others you can do. I find this the easiest one to remember, but it's up to you as long as it works. 1, 2, 3. 1, 2, 3. And you'd probably be doing this in pencil, just make sure it's nice and clear. So there it is. And each length is 3 centimetres. Question 9. Charlie works in a beauty salon. He has 3 appointments today. The time needed for each appointment is... Mrs. Green is 1.5 hours. Ms. Price is 1 hour 20 minutes. Sam is 3.25 hours. He will have a 45-minute break. Charlie will start work at 9:15 a.m. He wants to finish by 4:30 p.m. Will Charlie finish work by 4:30 p.m? Right, we've got a few ways of doing this. You can add up all the times together and then add them onto the starting time. Or you can do one at a time, if you like, and add them starting from 9:15. I think I'm going to do that actually. But also what I'm going to look at is I'm going to turn these into hours and minutes, I think, first of all. So 1.5 hours, I know that's 1 hour 30 minutes. This is in hours and minutes. 3.25 hours, well, that would be 3 hours. A quarter of an hour is 15 minutes and a 45-minute break. So if we start at 9:15, we've got to fit all 1, 2, 3, 4 things in. We need to allow for all of those. Now we're starting at 9:15, so I'll do this up here. Now I know that 15 plus 45 minutes will take me up to an hour. So actually I'm going to do this one first. I'm going to add on 45 minutes. And you'll see if we do 15 plus 45, that's 60 minutes. So that's going to take us from 9:15 up to 10 o'clock. So we can tick that one off, we've done that one. Now, which one do we want to do next? Well, we might as well do this one here. So 1 hour 30 minutes, we're going to want to add that on. 0 plus 0 is 0, 0 plus 3 is 3, 10 plus 1 is 11. So it takes us to 11:30. So we've done Mrs. Green. The order we're adding them on doesn't matter. We just want to know that they can be fit in throughout the day. Let's do Ms. Price next. So we want to add on 1 hour and 20 minutes. 0 plus 0 is 0. 3 plus 2 is 5. 1 and 1 is 2. And 1. So we're up to 12:50. But because we've gone past midday, this is now going to be PM. We've done Ms. Price. We just need to add Sam on now. So we're going to add on 3 hours and, 3 hours and 15 minutes. Well, we've got, 0, we can do it either way, because we've got the calculator. I'm going to do 50 plus the 15. Well, that's 65 minutes. But I know that there's only 60 minutes in an hour. So if we take off the 60, we're left with 05. But remember, we took off 60, so that's like we carried 1 across. So we've got our 2 plus 3 plus 1, which is 6. And 1 plus nothing is 1. So we've got 16:05. This isn't a 24-hour clock. But they've given us the finish time in a 12-hour clock. So we can either turn this into a 24-hour clock, or we can take off 12 hours here to turn it back into a 12-hour clock. So the 05 is going to stay the same. 6 minus 2 is 4. 1 to 1 is nothing. So if he's got to fit all of these things in. It can be done by 4:05 p.m. Will Charlie finish work by 4:30 p.m? Well, yes. And if we want, we can do 5:05 p.m. is less than 4:30 p.m. Question 10. Oscar is organising a show. Visitors to the show choose their seats at random. There are 350 seats available. These seats are numbered from 1 to 350. Oscar places a prize under each of the seats numbered 17 to 25. What is the probability that the first visitor chooses a seat with a prize? Well, the first visitor has got 350 seats to choose from. So that's our denominator. Now, winning a prize means I have to sit in one of the seats from 17 to 25. Now, to be sure how many seats there are between 17 and 25, I'm actually going to write them all out. 17, 18, 19, 20, 21, 22, 23, 24, 25. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 6. Now the mistake, almost what they want you to do, they're trying to encourage you really, is to say, well, let's do 25 minus 17. And if you do that, you'll find that you only get 8, which would be wrong. The reason it's wrong is because 17 is okay. So if you do want to do it as a subtraction, you actually want to say 25 minus 16. Because up to 16 you wouldn't get a prize, but 17 to 25 you would. But I think it's much clearer. Just write out the seats that you know will win a prize, count them up. We've got 9. So 9 out of 350, that's our probability. Then for the second part, the probability that a visitor buys a soft drink at the show is 3/4. Which of these describes this probability? We'll do it as a process of elimination. Is it impossible? No, because there's a probability there, so it can't be impossible. It'd have to be 0 if it was impossible. Let's go the other extreme, certain. Well, if it was certain, the probability would have to be 1. So it's definitely not certain. An even chance? Well, we'd need the same chance of it happening as not happening. So in other words, it'd need to be a half. Well, that's not a half. So it's either unlikely if it's less than a half, or likely if it's more than a half. 3/4 is more than a half, so it's going to be likely. Question 11. Holly works at a garage. Mr. Bakir brings his car in for a service. He also buys 2 tyres and a battery. Holly has this list of costs. So the cost for the service. Tyres are £49.99 each, but remember there's 2 of them. And a battery is £89. She uses this list to start to work out the bill for Mr. Bakir. Holly also has to charge 20% VAT on the costs to work out the total bill. Work out the total bill. And so it's going to be 110 plus 49.99 plus another 49.99 plus £89. So we've got 110. You could do 49.99 times 2 first, or just add it on twice. You'll get the same answer. So we've got £298.98. But remember, we've got 20% VAT to pay on this. So let's work out what the 20% VAT is. So 20 out of 100 times 298.98. We've still got that in the calculator. So we can multiply that by 20 divided by 100. So we've got, let's put it up here, so sorry about the light, 59.796. Well, this is money, so we only want 2 decimal places, so we're going to have to round the 6 up. So this is going to be 59.79 plus 1 is going to be £59.80. And then we need to add that, so this is the VAT. So we've got £298.98 plus £59.80 VAT, which gives us a grand total. We can clear this out. So 298.98 plus 59.80 gives us £358.78. That's our answer. Now there is a second part to this question, and it says use estimation to show a check of your answer. So there's different ways of checking. You could do a reverse check, so work back to the original, but they haven't said we have to do that. What I'm going to do instead is I'm going to check the total of the costs. Well, we said that the service was £110 and the tyres were £49.99. And we wanted 2 of those. And the battery was £89. Well, I'm going to do a bit of rounding. So I'm going to say £110 is approximately equal to £100. £49.99, well, that's about £50. And we want 2 of those. And £89, well, that's approximately equal to £100. Well, 2 lots of 50 is 100. So we've got 100 plus 100 plus another 100. It's about £300. Now, if we go back and see what we worked out, we had £298.98. Well, we can say 300 is approximately equal to £298.98. So we can say, okay, looks reasonable or looks sensible. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, turn on notifications so you find out when I upload more videos, and I look forward to seeing you again soon. Thank you.